Hello everyone! Today we are going to start the last section of Chapter 2. So our last section, since we've been jumping around, is actually Section 2. It's called Mixtures, and I'm splitting it into two parts. So before we begin actually talking about a mixture, let's review two important types of matter that we've been discussing. The first one is an element. So an element is the simplest form of matter that has a unique set of properties. If you remember from the other day, we said that it has one type of atom, and we also said that it cannot be broken down. So that's how you would describe an element, whereas a compound is contained of two or more elements, so you could say it's made up of two or more different atoms. And then here's the kicker, it's chemically combined. So yes, it can be broken down, but only by chemical means. So we can put can be broken down chemically. And compounds are in a fixed proportion. So remember, fixed proportion means that it's always going to come together the same way. So same way. This is an important distinction to make because these two things actually help tell the difference between a compound and a mixture. Before we move on to a mixture, again, I just want to illustrate and remind you guys that a compound and an element are both substances. That means their composition is fixed. So composition is fixed. Whereas a mixture, which we're going to learn about today, is a physical blend, so there's where the chemical and physical come into play, of two or more components. So what I mean by components is a mixture can contain both elements and compounds, and they can be mixed together. In fact, I just did a lab with my advanced chem kids where iron, salt, and sand was mixed together. Now, one thing I do want to talk about is we're going to hit on the next slide this whole fixed, and we're going to learn that mixtures are not fixed. So if you want to write that down, you can say mixtures are not fixed, their composition isn't. And another thing you can write down for mixtures that we're going to talk about in later slides is, yes, they can be broken down, but only physically. So if you want to break down a mixture, you break it down using physical means. So here is a good example of a mixture that we see in everyday life. If you go to a salad bar, you can get a lot of different things like lettuce, tomato, cheese, green peppers, avocado if you want that, cucumbers, croutons. Typically, customers choose what items they want on their salads and how much. So as a customer, I never get croutons. I hate them, but I get a lot of dressing. I love dressing. So each salad mixture that you get at the salad bar has different types of things. So like I said, I might not get croutons, but somebody else will. And different amounts. So like I said, I like a lot of dressing, but somebody may not like a whole lot of dressing. So since you can have different types and different amounts, here the composition is not fixed. You can get differences. Now, most samples of matter are mixtures, and most of them are pretty easy to recognize, like the salad we discussed before. Or you can easily recognize that chicken noodle soup is a mixture because you can see the chicken, you can see the noodles, and you can see the broth and tell that they're all mixed together. However, some mixtures are really actually difficult to tell, and the reason is because they look a lot like compounds. They look like they have a uniform, fixed composition. However, if you actually look closer, air is a mixture. It's a mixture of gases, so gases that are in the air can be nitrogen gas, oxygen gas, hydrogen gas, but even CO2, which is a compound. And the most important one we're going to talk about is water. So air can actually be dry. If you've ever been down to a desert, you get that dry air. That's because there's not that much water in the air. Whereas if you go to the rainforest, the air is more humid. You just feel sticky and wet. And that's because there's a lot of water vapor in the air. So since this water vapor amount can be different, the composition, again, is not fixed. It can vary. You can even see this in day-to-day life. Sometimes we have dry days and sometimes we have super humid days right before rainstorms. Okay. So how can mixtures actually be classified? Just like substances are broken down into two categories, matter is actually also broken down into two categories as well. And it's based on the distribution of their components. So what I mean by distribution is how they are spaced out. One way you can classify them as a heterogeneous mixture, and the second way as a homogeneous mixture. So let's talk about each one of these one by one. The first one we're going to talk about is heterogeneous mixture. This is a mixture in which the composition is not uniform throughout. So I like to say that you can see the different components. So if we use our example that we've already had, salad, I can see the difference in the cucumbers and the onions and the lettuce. That is an example of a heterogeneous mixture. Same thing with cereal. I can see the difference between the milk and the cereal. They're mixed together. The one that your book uses is chicken noodle soup. You can see the difference between the chicken, the noodle, and the broth. Also, if we were talking about distribution, it's not evenly distributed. You can tell, like I said, you can tell that difference. And when you go to eat it, you get different amounts in your spoonful. Sometimes you get a lot of chicken, sometimes you get a lot of broth. Sometimes, if I'm lucky, I get noodles before they fall off. So here you get different amounts. The next one we're going to talk about is a homogeneous mixture. This is where the composition is uniform. I like to say that it looks the same. Homogeneous mixtures are probably the hardest ones to tell because a lot of homogeneous mixtures look like compounds because you can't tell the difference. You can't see things mixed together. And the reason is because this distribution is so close. It looks like it's evenly distributed, so it looks like one thing. So right here, this is olive oil. All of its particles that are mixed together are evenly distributed, so it doesn't look like a mixture. Same with vinegar. But in fact, both of these things are mixtures. Vinegar is a mixture of water and acetic acid. So again, all we did was took acetic acid and we dissolved it in water, and it looks the same, but it is in fact a mixture. Now, both of these are homogeneous mixtures, and another name for a homogeneous mixture is known as a solution. So I will ask this on your test, what a solution is. All it is, again, is another name. So solutions, or homogeneous mixtures, most of them are actually liquids. If we think about it, we already talked about olive oil, we talked about vinegar, but we also have things like French dressing, salt water, sugar water. All of those are homogeneous mixtures. However, some of them are considered gases, like air is a mixture. It can have different levels of gases in them. Like some may have more water vapor and some might have less, like we talked about before. And some homogeneous mixtures are even solids. If you've looked at stainless steel, a lot of different things like silverware or equipment that you use around the house can be made up of stainless steel. It looks the same. It has that bright, lusty silver appearance, but it's actually a mixture of three elements. And these three elements are iron, chromium, and nickel. So those elements mix together to form stainless steel. Another one that might be a solid that you're going to see is going to be bronze. Bronze is actually a mixture of copper, I believe, and tin. Since we're on this homogeneous mixtures, we're going to talk about something known as a phase. A phase is one of those words that people usually get confused often. So if you're one of those ones that are taking notes on what to study, this is the number one thing people get confused on. The reason is because the definition is it's a part of the sample with uniform composition and properties. And that definition sounds an awful lot like homogeneous. So that's usually where they get it mixed up on the test. So a phase is just how many things can make up that mixture. What does it look like? If you have a homogeneous mixture, we say that it consists of a single phase. And that's because when you actually look at this, it looks like it's only one thing. It looks the same, so we consider this one phase. Over here, it looks the same, so we consider this one phase. However, a heterogeneous mixture is two or more phases. So for example, if we take oil and vinegar and we mix them, we get what looks like down here, two layers. These layers, I guess you would say, are phases. So here's one phase and here's two phases. If we were to go back to the example of the salad, a salad is a heterogeneous mixture, so it has more than one phase. If you have 5 different ingredients in salad, there are 5 phases. If you have 8 ingredients in a salad, there are 8 phases because I can tell the difference between all 8 of those things. So at the beach, you realize that both ocean water and sand are mixtures, which is homogeneous and which is heterogeneous. So let's review what these two terms mean. If you are doing homogeneous, remember that means the same or looks same throughout. Heterogeneous, hetero means different. You can see different components. So if you have some salt and you actually dissolved it into water, you get some salty ocean water. And when you look at it, it actually looks just like water. You can't really see the salt in it because it's dissolved. So if you said that the ocean water was homogeneous, you are correct. Whereas sand, if you look at sand, you can kind of see different colors in it. You can see some black particles, some brown particles, and some like clear crystal particles. And that's because sand, since you can see the different parts of it, sand is considered a hetero mixture. So salt water is homogeneous and sand is heterogeneous. This is the last part we're going to talk about before we stop, and it's how to distinguish substances and mixtures. So deciding whether something is a substance or a mixture based on just appearance alone can be a little bit difficult. So right here, if we have a substance, remember a substance can be an element or a compound and a mixture. So after all, homogeneous mixtures and substances usually look like they are one phase or they look the same, so they appear to have only one kind of matter. So what you can ask yourself to distinguish between these two is the composition of the material fixed? And if the composition varies, it's a mixture. So again, if it's fixed, it matches up with a substance. If it varies, it matches up with a mixture. So one way to decide if something has a fixed composition is to see if there's more than one version of it. So for example, milk is a mixture. It is a homogeneous mixture. And the reason it is a mixture is because you can buy whole milk, low-fat milk, no-fat milk, light cream, heavy cream, and we can conclude that milk and cream are mixtures because there are different types. In fact, the way that they're different is they contain different amounts of fat. If you get 2% or milk, it's going to contain less fat than if you got whole milk. Heavy cream has more fat than light cream. Another example of this version is gas, or like gas that you get to fill up your car. So gas is a mixture, and it's a homogeneous mixture. If you go up and take your car to the gas station, there are usually different options for gas. The typical option is you get 87, but I've seen 89. If you get to a big city, you can get 91. And that's because the gas has different levels of octane, or sometimes they have different levels of ethanol added. And so these are considered a mixture because there is that difference. Okay. So this is a picture that you have in your book. I've edited it just a little bit. Here you have matter. And the first thing that you can ask yourself is two questions. One question that you can ask yourself is, can it be broken down physically? If you said yes, it is going to be a mixture of something. If you said no, then it has to be a substance. So again, it has to either be an element or a compound. Another question you can ask yourself is, does the composition vary? Again, if you say yes, you have a mixture of something, so variable composition. If you said no, that the composition does not vary, then you have a definite composition and it's a substance. So let's go over here to the left. The next thing you can ask yourself once you know that it's a substance is you can ask yourself, can it be broken down chemically? If the answer is no, it's an element. If the answer is yes, it is a compound. And then you can further break down a compound into an element. Now if we go to the right, if we know that, hey, it can be broken down, this is going to have a variable composition. And in fact, we can continue to break down mixtures physically until we get to a compound. So again, that's why if you see the picture in your book, there's another arrow right here, but I have widened it out. Once you have this mixture, you can ask yourself, is it uniform throughout? If it looks the same throughout, it is homogeneous. So it's uniform and it's called a solution. If it's not, if you can see those different parts, it's non-uniform and it's considered heterogeneous. So that's the end of the lesson. If you guys have any questions, please let me know because I am more than happy to help you. Have a good day.